All right, first, let's actually run a test from start to finish. Let's do the 4-step process. Okay? So first, what's the problem? Recall the potato chip producer from earlier. If the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load. Otherwise, the entire load will be used to make the chips. The chip producer has just received a truckload of potatoes from the supplier. A supervisor selects a random sample of 500 potatoes. An inspection reveals that 47 of the potatoes have blemishes. Is there convincing evidence at the alpha equals 0.1 level that more than 8% of the potatoes have blemishes? Okay. Now notice they've changed the alpha level. If they don't tell us, we use 5%. But here, they're very clear. They want us to test it at the 10% level. That means that the p-value must be less than 10% for us to reject the null and ship the potatoes back. Okay. Is this categorical or quantitative? That's the first question we want to ask. Oh, this is categorical. Is the potato have blemish? Yes or no, right? We don't give it a numerical value. So what do we want to do? I'm going to label these, but we might not always do this, but what is step one? Define the parameter and write the null and alternative. So in this case, P is the true proportion of potatoes that have blemishes in this truckload. Still not done with step one because I haven't wrote my null and alternative. So the null, the HO, H naught, P equals 0.08. Remember, the null is always, no, there's no difference. It is as stated. It is as claimed. Versus the alternative, what are we worried about if the truck has too many blemishes? So we would say greater than 0.08. Now we've done step one. Okay. So remember, step one, what are we going to do? We're going to test is the true proportion of potatoes that have blemishes in this truckload greater than 0.08? Step two, are we allowed to do it? Check conditions. SRS, supervisor selects a random sample. So randomly selected. We're okay there. Whoops. Independence. Is the population at least 10 times the size of the sample? So assume the truck holds more than 500 times 10. So we're going to have to assume that this truck holds more than 5,000 potatoes. Normality. Does n times p naught and n times 1 minus p naught, are they both greater than or equal to 10? Well, let's find out. So to check to see if the data is approximately normal, and we can use these scores in our favorite table A and our favorite standard normal curve, we have to check to make sure that it's normal. So if it's normal, then n 500 times p naught 0.08 and n times 1 minus p naught both have to be greater than or equal to 10. Well, this is 40 and this is 460. They're both greater than or equal to 10. Yes, we are allowed to do this problem. So remember, step one, what are we going to do? Step two, are we allowed to? Step three, let's do it. So step three, we need to calculate the test statistic and the p-value. My guess is most of us will use technology to calculate the test statistic. So let's come back here and let's run through this process of calculating the z-test statistic. Remember our favorite button, stat. What are we going to do? Oh, we're going to run a test. What kind of test? A one proportion z-test. The null, yep, it's 0.08. Whoops, somehow I put that next. The null is 0.08. X, how many bad potatoes did we find? Oh, 47. Out of how many did we check? Oh, 500. What is the alternative we're looking for? The alternative is greater than. And then let's let the calculator do the work for us. Calculate. We got a z of 1.15 and a p-value of 0.1243. So z of 1.15 and 0.1423. So let's make this a little bigger so we can write on here again. So our z test statistic, 1.15. So our z-test statistic was 1.15 and a p-value of, I forgot that already. I think it was 0.12 something. Let me take a look real quick here at our p-value, 0.1243. All right, so we did it. What are we going to do? Are we allowed to do it? Do it, and then what the heck does it mean? Okay, so finally, what did we find? We found that the data was significant or not significant. Oh, this p-value is greater than the alpha level. Therefore, we fail to reject the null. Okay. The data was not statistically significant. The p-value is greater than the alpha level. So we fail to reject the null. Therefore, we keep the batch of potatoes. Okay. Since this p-value is not all that unlikely, what does this p-value mean? Assuming that 8% of the truck is bad, the probability of finding a sample such as the sample that we found would happen 12.43% of the time just due to sampling variability. We do not have enough evidence to reject the null. Therefore, we would accept this truckload of potatoes and go make some chips. I'm ready for some chips right now. I think it's lunchtime. All right. What if the test is two-sided? Say, let's do another example from beginning to end. What are we going to do? Well, I don't know. Let's see what this problem's about. According to the Centers for Disease Control, 68% of high school students have never smoked a cigarette. Statistics class project in Yahong surveys a simple random sample of 150 students from her school. She gets responses from all 150 students, and 90 say they have never smoked a cigarette. Is there convincing evidence that the CDC's claim does not hold true at Yanhong's school? Okay, so what are we going to do? Okay, step one. Have you smoked a cigarette? No. Yes. No. Oh, it's categorical. I didn't answer those questions with a number. I answered that question with a word. Therefore, I know this is going to be a proportion. So what am I going to do? I'm going to do a 1 prop z test. What is P? The proportion, the true proportion of students at what's her name? At Yan Hong's school who have never smoked. or at least who claimed to have never smoked. Well, what is the null? No, Yunhong School is the same as the rest of the country, which is 68%. But what does she want to test? That her school smokes more, smokes less? It just says, is there convincing evidence that the claim does not hold true? So Yanhong's experiment is not that my school smokes more or less, it's that my school smokes a different amount than the national average. So therefore, this alternative would be two-sided, meaning that P does not equal 0.68. All right. Now, are we allowed to do this problem? How did Yanhong sample the students? A random sample. So SRS, they told us. Independence, assume more than 1,500 students at her school. Okay, if that's true, then we're all right. And then normality. Well, N, 150, times P naught, 0.68, and N, 150, times 1 minus P naught, 0.68. Both must be greater than or equal to 10. So what is 0.68 times 150? Let's find out. 0.68 times 150, I should be able to do that in my head, 102. So 0.68 times 150 is 102, certainly greater than 10. And 150 times 1 minus 0.68 is 48, both greater than or equal to 10. So it's normal, it's randomly selected, it's independent, and it's normal. So we're okay. So we stated the problem. What are we going to do? Find the proportion of students at Yanhong School who have never smoked. Write the null and alternative. We did that. Are we allowed to do it? It was random, it's independent, and it's normal. Cool, we are allowed to do it. Now let's do it. Let's calculate the test statistic. Since this is proportion, we're going to use a z-test statistic. Z is going to equal, Z equals P hat. So P hat in this case is 90 out of 150. So what proportion is 90 out of 150? We need to convert P hat to a decimal. So 90 divided by 150. Oh, 60%. Is that different than 68? It is, but is that difference statistically significant? We don't know yet. Okay. So 0.6 minus 0.68 over the square root of 0.68 times 1 minus 0.68 all over n. So when I do that calculation, I'm going to find that this z-test statistic is equal to negative 2.1. So the alternative here is two-sided. So let's look at using table A to find this p-value. Whoops, I thought I grabbed it. Let me grab it and bring it over here so we can take a look at it. So my z was negative 2.1. Negative 2.1 is 0.0179. 0.0179. Okay. So my p-value equals 0.0179, but that's not truly my p-value because my alternative is two-sided. So I need to look at the area in both tails. So when I standardize, remember, I convert it to this curve. Negative 2.1, that would be this area out here. Let me color that a different color. So that would be this area out in here. That area is 0.0179. However, this is a two-sided alternative, so I need that area in both tails. So I have to take this 0.0179 times 2 to get my actual p-value. So 0.0179 times 2 would be 0.0358. All right, so that's my p-value. Assuming that Yanhong School smokes the same as the rest of the nation, there is a 3.58% chance of finding a sample proportion of 0.6 or less. So if her school smokes at the same rate, there's a pretty small probability of me finding the sample that I did. Therefore, I don't think her school is the same. So finally, let's interpret in context. Okay. Let me change the color just because I got so much on this page. Maybe it'll be easier to distinguish. I probably should have done each step in a different color. All right. Let's write our conclusion. P-value is less than the alpha level. Therefore, the data is statistically significant, and we reject the null and conclude that the students at Yanhong School do smoke at a different rate than the national average. All right, so we looked at one-sided alternatives and two-sided alternatives. But so far, we've really only been focusing on categorical data, proportions.